Last one of these. I get to go home. You get to be done. This is only half of the concepts that are covered on the final, though. There's going to be another one of these next Friday. So you need to pass the assignments. Let me show you. You have until the end of the semester, which is before Christmas break, to finish the following things. You need to finish Chapter 6, all of Chapter 6, and then all of the finals review before you leave. 1 through 8 was the first test review, and 15, I'm thinking, 9 through 15 is going to be the second one. If we get to sequences, then we'll try it, but I'm thinking that I'll delete those before we get to them. So 1 through 8 is going in now, this weekend. 9 through 15 is going in next weekend. So you can see that there's another half of the subjects that we need to cover for the next finals review. That's a final for you. It's cumulative. So let's see. The domain goes from left to right. Domain. So the domain in this case was between -3 on the left and 9 on the right. And then the range is from top to bottom. Top is here, and that's the range. It is f of t, which I'm going to call y here, up and down, is in between -3 again, and the top of it is at 6. Alright, so from left to right it goes from -3 to +9, and from top to bottom it goes from -3 to +6. The first question, anything that doesn't, basically anything that lives further out, like -6, is not inside that domain. And then the other one doesn't make any sense because it asks what t values are the range. The range is not the t value, the range are the y values. So if you would, for example, put t here, that would have been totally wrong. T is left and right. The range is the up and down variable, that's y. Alright, next question. None of these lines fit these data. These data are all over the place. Match the correlation to the graph. Let's label 2 of these positive and 2 of them more or less negative. This one is positive, this one is negative. This one is basically positive but less so, and this one is more or less negative. I know that that looks like a NOR correlation, but that's actually a very weak correlation. So I got 2 negatives and 2 positives. 2 negatives, or let's look at the 2 positives. This number here, the 0.88, is closer to 1, so it belongs to the one that is more tightly packed. I would claim that A is more tightly packed than D, and so this one is going to be the stronger correlation. It's going to be closer to 1 than this one. So this is going to be D, and this is going to be A. And then I have 2 negative correlations. This one is a very tightly packed, so that's the strongest correlation, and it's negative. B, and then this is a very weak correlation, something like -0.33, because they're not very bunched up at all. So it's negative because it's a negative correlation, and then 0.33 because the data points do not line up all that well into a ordered line. I'm intending to be comparing and contrasting yet again linear with exponential. So 75 people reach the summit every year, and because that goes up the same rate, it's linear. So 75 people extra every year. So 75 every year has to be the slope times x for the years plus 2 to start with is the number of people that live there. So the people that reach Everest, 75 extra do so every year plus 2 to start with. So for example, if it had been going for 2 years, then that would be 152. So that's that equation. The other one is a percent, and so I know almost every percent is an exponential situation. It's 2%. 2% is the same as 0.02, which means that I have a factor of 102% or 1.02. So I multiply by 1 to keep the old amounts plus 0.2 or plus 2% every time. So there is 1.02 times as many times as visitors at the Eiffel Tower every year. So y equals 1,000 to start with times 1.02 for 2% raised to the number of years is the model for that one. Distributed property is the one that has parentheses. It's this one here. A times B, B, A times C. Oops, ooh, my typo. This should have been A times C. I'll fix that right now. All right, and that is it. That was the first half of your review for the final.